When we think about fitness landscape, so fitness landscape, we think about, let's say, two traits, trait 1 and trait 2. And here's the fitness maximum. And here are the fitness contours, like a hill going down around the fitness maximum. And sometimes we think about variation. Variation might be, you know, like going from the top of the hill down to some lower level. And that's the explanation for variation. Equals fluctuation around the maximum. In the Pareto picture from Shoval 2012, there's a completely different reason for variation. And I'll try to explain. So this is a different concept that relates to fitness landscape. So again, we have our trait space, trait 1, trait 2. But this Pareto picture says that there are different niches or environments. So in one environment, you might have this fitness landscape. Okay, so this is environment 1. In a different environment, you might have this fitness landscape because the different traits are the best. And here you might have a different fitness landscape. So variation is here because of different niches. But the beautiful thing is this variation has some rules or constraints, and that is, if there are 3 tasks, so if fitness depends on 3 tasks, so that if you're better at all tasks, you have higher fitness, then Pareto picture predicts that all the different landscapes and all different environments will fall in a triangle. And at the vertices of these triangles will be the archetypes, which is the fitness peak of a fitness landscape if there was only one task. So in an environment, it could be an imaginary environment, it was only task 1, you would have this fitness landscape, and its maximum is the archetype. And if you had only task 2, you'll get this fitness landscape, only task 3, you get this fitness landscape. And the theorem says that no matter what the niche is, as long as it depends on these 3 tasks, no matter how it depends on these three tasks, the fitness maximum should be somewhere in this triangle. So data should fall, the variation between data is not due to fluctuations around a single fitness landscape peak, but instead to different niches, and the data should fall in a triangle. And then the usefulness of this theorem is that if you look at the triangle, you can infer what these archetypes are, and if you look at the species closest to each archetype or the data points, they should specialize in this task 1, let's say, and then you can try to infer what the task is. So at the end of the day, you have a more detailed picture where instead of a single fitness scheme, you have the fitnesses made depending on 2, 3, 4 tasks. If it's 2 tasks, by the way, you get a line. If it's 4 tasks, you get a tetrahedron. So you can look at the data, infer the number of tasks, and then guess what the tasks are by the specialists nearest those vertices, and you get a richer understanding of the fitness components or the tasks. So that's the difference between the fitness landscape picture and the Pareto picture.